Good morning, good afternoon, and good evening. I'm Mukundan Govindaraj. I'm a solution architect for OmniWorlds from NVIDIA. I've got over 15 years of experience working in building 3D worlds, building interactive worlds, digital twins across the various industries. All right, on today's session, we're going to talk about NVIDIA's OmniWorlds, and we'll see around how it empowers creators to create metaverses and digital twins. And we'll also see some pretty cool videos, show reels, and also some interesting use cases. So you must have, you've been hearing this a lot on the internet, right? Metaverse. And of course, through social media as well. And more likely, your company is already working on a strategy for metaverse too. And some of the audience whom you're watching this video, either you are already building a metaverse or consuming the metaverse, either one of the two. But whenever we do that, we keep revisiting this fundamental question: what is the metaverse? And of course, there can't be one answer justifying, as it's constantly changing. But simply put, it is the next evolution of the internet. Today, majorly we interact with the digital worlds through a flat screen, two-dimensional interface, be it your laptop or your mobile device. The metaverse is meant to extend all these two-dimensional, flat displays into AI-driven three-dimensional spaces. We are talking about connected virtual worlds or the virtual extension of a physical world. So it's not only transforming the way we see things, it's also changing the way we live in a metaverse. The natural evolution of metaverse from the nascent stage it is in right now and to the stage where it is going to become in the next few years, there is a huge demand for photorealism and a lean handheld device, powerful data centers, and physically accurate worlds which obey all the laws of physics in the real world. And it will also be not inhibited just by human avatars. You will also see AI beings interacting with you. Now, we can look at metaverse as two components. One is the consumer version, and then we have the industrial metaverse. Consumer metaverse is all about how space looks, how the social experience can be enriched, and also to some extent decentralized payments. Right? So industrial metaverse on the other side is all about photorealistic visualizations and physically accurate simulations. So here we are talking about very precise simulation of a fire, very precise simulation of maneuver of robots. And we want them to obey all the laws of physics as it would in the real world. So there is an immense need for accelerating the current 3D world creation process. The volume of 3D worlds that we'll be creating and churning out in the next so many years is nearly impossible with the current computing power and in the current 3D pipeline that we are following, which is very linear, and also the available manpower. We are spending a lot of our valuable time and efforts into doing all those repetitive world building tasks. The industrial AI, they also require a 1:1 scale, diverse, and accurate data in order to create these true digital twins. It's basically impractical and also in many cases impossible to create such data because we are talking about a digital twin where the foundation is not laid even in the real world. The only way to produce such data is by synthesizing it. And for the AI to be really successful in creating this data, we need to train them in a virtual environment, which is not only a visual replica of the real world, plus it should also obey all the laws of physics to an extent that whatever you simulate in the virtual world will be a true replica or a true digital twin of your real world. So I would like to talk about the major challenges that we are facing in the current industry, especially who is involved in building 3D worlds or digital twins for that matter. So firstly, we have already shifted towards a hybrid working model where a lot of us are working remotely and most of our teams are sitting across the globe, and we are in a dire need to be collaborating seamlessly like we would in the real world. The 3D process by itself is a very complex process. For people, I'm sure, who's working on it, they could relate with it. The process is a linear, which means you start with modeling, then texturing, rigging, animation. The file has to go through literally several departments before it could be handed over to the developers. And then when there are feedbacks and changes, you again have to take it back to ground zero and then start making all the changes and then pass it on. So this is extremely time consuming and it burns a lot of energy. And during this process, it's creating a lot of data, which we are calling as data dump here. So after going through all these hazels, now when you try to go and make changes on top of it, we are actually in between, we are creating too many file formats. So when you're working on a DCC tool, they have their own file format. And then when you shift it to another tool, then there is a new format which gets introduced. So all the changes that you're doing on top of it, it never sits on move, it cascades down to the ground source, which means you're adding layers of information on top of it. And when you go and make some changes at the ground level, again, you are forced to make more changes on top of it. So in order to disrupt this entire system, we need something where you will have one single file format which will be universally accepted in world building so that you don't have to go through this hassle on a day in and day out. So Omniverse is purely present in order to address all these challenges. And Omniverse is a platform which lets you build and simulate virtual worlds which are true replicas of real world. It is meant to accelerate the 3D workflows, and also it provides a powerful suite of tools including ray tracing, physics simulations, and synthetic data generation. So you can quickly build virtual world by plugging Omniverse to your current pipeline, and you'll see what a kind of a difference it could bring on by saving a lot of time and efforts. Now let's watch a quick video, and from there we'll take it. So those are some of the interesting work where Omniverse is being used. So on the Omniverse enterprise platforms, users with different skill sets using different tools can collaborate seamlessly. It eliminates the tedious process of importing and exporting assets from while you're working on different DCC tools or game engines. So here is how. So on the left, you see the collaborators. So let me go and use a laser pointer. Yes. So these are the various collaborators. So you see a modeling artist and a sculpting artist. Then you have a texturing artist and a looked out person. And then you have level designers. So while they're working alone on their DCC tools of choice, they can collaborate in real time so that each one can see what the other person is doing, plus whatever changes he's trying to do. Either you wanted to save it separately, you could, or you can also cascade it down to the single source of file. And in the center, there is something called Nucleus. Nucleus is our storage and collaboration server, and which is one of the most powerful core component of Omniverse offering. So Nucleus is by default built on some of the path-breaking technologies which NVIDIA has been offering for the last 20 years, which includes physics, materials, realistic path tracing RTX renders, then also the powerful AI offering. Plus, in order to empower this entire ecosystem to work towards one single source of truth, the entire Omniverse is built on the foundations of Pixar's USD file format. So this is the most powerful format which is available right now, and it's also being considered to be the HTML of the metaverses. On the right, you see the RTX renderer. So using this, people can portal in and out. If you're a creative director or a client, you can simply portal into Nucleus with your DCC tool or some of your Omniverse application to see what is happening in the world building that the team is working on. And also, you can embed XR solutions through which you can see the beautiful worlds and the characters that you're building real time in AR and VR devices. Omniverse wasn't possible until now. First, we had introduced RTX technology, which completely disrupted the way real-time rendering happens. So initially there was rasterization, which was set as the standard for game engines, but then NVIDIA completely revisited the real-time rendering with RTX technology. So you get physically accurate, reactions because of the materials that we use there, and also photorealistic output purely because it was tuned and it was built on the powerful GPU's churning processing, which means you're able to get visually accurate and also at a very short time. Then GPU computes have already started taking over the entire world. So what initially used to be CPU-based data centers, now people have started understanding the power of GPU and have also started shifting, because GPU-based compute centers are highly scalable and it could provide you an output at a very short span of time. The third major bucket is the USD, which I already spoke to you about. So we want to have one single source of truth by using USD as the file format. So USD is a little beyond and above and beyond file format. It's not a format for your model or for texturing, but it's a format for your entire 3D world. It can have geometric information, can have textures, materials, animations, simulations, volumetric, or even particle, whatever it is, you can have them all there. Then NVIDIA has been already working heavily in creating synthetic data and simulations, which is again being one of the strong technology offering as part of Omniverse. So overall, when you start using Omniverse, you will see visible decrease in the time to deliver. And of course, you're saving a lot of cost there. And secondly, since it enables collaboration, it kinds of throttles the creativity and thereby also improves the end product output. Plus, while you're working on these entire ecosystems, since most of our operations are GPU based, you are actually putting to use the maximum power of what a GPU can offer. These are the 5 foundational platform components which drives what NVIDIA Omniverse is. Nucleus, which we already saw, is nothing but our storage and collaboration server. So people working on DCC tools and game engines, they can simply connect with Nucleus so that they can start collaborating out of the box. Connect is nothing but a plugin which enables people to connect with Nucleus. So there are again different types of connectors, which we'll again see in detail in such shortly. Kit is the SDK, which is based on which the entire Omniverse applications are built. So there are microservices, there are applications and extensions, which all can be built using the base Git SDK. Then we are talking about physically accurate simulations, which is again powered by physics engine provided by NVIDIA. Plus, you can also do volumetric simulations using Flow, and also break some walls using Blast SDK. Then we have the powerful RTX renderer, which helps you visualize the beautiful world which you're already building in the most accurate, photorealistic way. So again, this is a very high-level architecture of how Omniverse Enterprise version sits in your current pipeline. So on the left, you see the various DCC tools that you will be working on. Then you connect to the nucleus, which is in the center, which acts like a storage. Plus, it can also run a lot of microservices, which will help you in your file management, user management, and also make your pipeline much more robust. Plus, there are a suite of applications which are provided out of the box from NVIDIA, which lets you start building these beautiful worlds and review them. And finally, you have the user interface, the end user application, which is running on workstations, laptops, and wearables, through which you can portal in and out of the virtual worlds. Just to reiterate again, USD is the foundation technology on which Omniverse is built. Just to give you some context, Pixar is known for pushing their boundaries and also continuously reinventing what they do. And they identified the major gaps that they are facing in their current industry, which is 3D and VFX. So they introduced USD as a format after 30 years of research, which kinds of answers all the shortcomings of the current pipeline, and it introduces a non-destructive pipeline where people can collaborate seamlessly. At the same time, you maintain also a source of the truth at one single source. Plus, it is highly scalable, and it's also very widely adopted across all visual industries, including art worlds, product design, and also robotics. It's highly extensible and very flexible. Plus, it also has some APIs using which you can programmatically control the scene that you're building. And there's a lot more to read about USD. I would highly recommend you to check out the documentation page. And also, there are a lot of videos available which talks a bit more about USD and its powerful features. So again, we saw a bit about Nucleus. Now I'm going to go in detail about what it is. It is your storage and collaboration engine. Let's say this is one of your DCC application, and then this could be your game engine. So what you will do is you will have to install the connector, which kinds of sits inside the client application. And whatever be the format your client application which it generates, it gets converted into a USD library, and then it will go and sit in the Nucleus server. So this enables people to work seamlessly. And only the first time when you open it might take some time for you to export the files. But the subsequent load is super fast because only the changes in file gets transmitted real time. Here is a quick video which will give you some insights on how real-time collaboration would work. On the top left, you see that one of the modeling art, there's a level design artist who is working on setting the levels. And right here, one of the texturing artists is using Substance Painter to create some beautiful artwork. And beneath that, we see one of the modelers who's creating a model on the fly. Right here, the entire level designing and the lighting is taken care in Omniverse Create. And what you see here is there are 4 different people working from 4 different places using 4 different tools, but all the interaction and collaboration happens seamlessly. So which means just saving a lot of time, and also it's boosting creativity to a different level. Again, Kit is nothing but the powerful SDK. So there is already a lot of solutions which you can use out of the box. But if you feel that there are some specific needs for your current 3D pipeline, and you want that flexibility to go and build a new feature, not to worry, you can simply go and start using Omniverse Kit, using which you can go and build an extension or a microservice, or put a lot of extensions together and create your own application. So this is a very interesting and a very powerful modular kit which is available, and you'll see how powerful it is only when you start using it. So when you talk about physics, there are actually 3 different types of physics. One is your real-time physics engine, and also if you would want to import physics from different physics engines that you might be already using, some engineering physics engines, yes, you can also do that. Plus, if you're working in a very accurate industrial problem which talks about very accurate physics simulations, then you can also use our NVIDIA's modular physics engine, which is built for industrial accurate physics simulations. It's very highly graphic intensive, but it's also very highly accurate, and a lot of clients use it for specific recreation of a physical real world physics. So if you look at the basic physics engine, you have 3 types. You can work with rigid bodies or soft bodies. Plus, you have a physics blast, which lets you play with fracturing and disruptions. And also using flow, you can create volumetric effects, which includes fire, smoke, blast, and a lot more than that. So once again, RTX renderer is a scalable photoreal real-time renderer, which is again built on NVIDIA RTX tech. It's a renderer built to simulate a world as faithfully as possible, while also providing scalability to the users to increase quality. And also, you can run it across multiple GPUs at the same time, which means it's going to cut down the final time to deliver to you. We can talk about it in detail, maybe as in a follow-up session. So look, out of the box, we have a couple of apps which I would like to talk about. We have a lot more than that, but these 2 powerful apps will come in really handy if you want to get started with Omniverse today. Go and download Omniverse Create, and its main purpose is to go and build beautiful worlds. So you have a lot of free assets, you have a lot of materials, and all the lightings that you would need to do with literally like a half an hour of a learning curve. If you already have some prior experience in some DCC or game engines, with less than half an hour, you can start building some really beautiful worlds. So that powerful it is. I would highly recommend you to download the app and play with it. Then we also have another app called Omniverse View. The main purpose of this app is to review the great worlds that you're building. And also the Omniverse View app is for people who do not have much experience working on hands-on, but for people who review. It could be your director, or it could be a creative director, or even in fact one of the CXOs. So now we'll just simply go through some of the industrial use cases. Again, we have a lot. Maybe we'll just handpick some of them and we'll go in detail about that. Yeah. So we go and understand some of the use cases. I also would like to suggest some early adopter use cases. What I mean by that is like, what can you do with Omniverse Create out of the box, like for early beginners? So you can use Omniverse to create a space for visual designs while you're working on a product design or even an archivist projects. you can simply go ahead and import your models, start lighting the scene in a very short span, start rendering and come with beautiful outputs. And it also helps you in real-time collaborations, which mean projects which require different people from different places to come together, creative jobs. You can start using those projects as well in OmniWorlds. For design reviews, it comes in very handy. Plus, if you're also working on virtual production, where you want to shoot an entire ad, or even for one of the movies, you can simply start using OmniWorlds Create, which gives you all the power to go and do virtual production. So here is a great collaboration between NVIDIA and Industrial Light Magic. You must be already aware what great job that ILM does. So we partnered with them in identifying and restructuring the entire process of 3D building and VFX pipeline. We are exploring several opportunities here and identifying the areas where we could improve, and we can also disrupt and make sure the efficiency is boosted to the maximum. The potential to improve the creative process through all the stages of VFX and animation pipeline will be highly transformative. With WPP, which is one of the world's largest creative agencies, we created a virtual production completely for one of the ads. So the entire ad was shot in virtually created space, including the vehicle and the forest that you're seeing in the background. So this actually helps you in saving a lot of cost and time that you would have otherwise spent in going and shooting in this real world. So with Volvo, we partnered in various aspects of car production, starting with research and also the design of the car itself. So this was a very successful use case for us. And we also realized that we have much, much more need for using collaboration and very photorealistic output during the design phase. DNEG is another VFX giant in the world with whom we are again partnering and simplifying and also seeing how we can boost the efficiency of various stages of production. I'm going to quickly show an example. So what you see here on the left and center. So this is how currently, if you would want to review the file on a Play Blast for especially a complex character like this bear would look like, because hair simulation takes a lot of time, and in order to even render out a frame, we are talking about few minutes to an hour. But in the center, with the power of Omniverse, you are actually able to see the entire character along with the most complex hair simulation in real time. So this is actually giving a lot of power for the animator, because as an animator, when I'm working on an animation, if I'm going to work on a model like this, I may not be able to actually get to feel how it would look after it gets rendered out, because we are only animating the skeleton and the visible mesh. But on top of it, we are going to have a coat of hair which is completely ignored in a Play Blast. On the extreme right, if you see, we are also having another layer of interaction on top of what we can show real time. Here you also control the lighting, the environment, the camera angle, so that as an animator, I get super powerful perks in my hand, so that my animation looks more real, and also I don't have to work on the blind spots, especially when I am animating. So I'm saving a lot of my time, and I'm channelizing all my efforts onto that camera angle, which I'm actually going to see in the output. So here is another comparison between a Play Blast and the same animation which is running real time on Omniverse Create. So on the right, you see all the post-processing effects, the fog, also the volumetric lights, and the materials also, it takes up realistic lighting. And as an animator, when I get to see this output while I'm building the animation, it gives me more decision-making power. At the same time, my output is also very well optimized. Let's see a quick show reel where we showcase some of the cool products that are built using Omniverse.
See you in Omniverse.
So now I'm just going to walk you through some of the commitments from NVIDIA and our path forwards towards empowering metaverse. Metaverse requires a robust and a powerful computing platform to support linking the digital and the physical worlds together. NVIDIA has been building the core technologies over the last 2 decades, and these core technologies are so powerful and they are already empowered by the NVIDIA's high performance computing platforms from edge to the cloud. NVIDIA is committing to launch very powerful tools under the umbrella of neural graphics. So neural graphics again intertwines AI and graphics together. As if you remember, I've been mentioning about that even in the beginning, where we need more machines doing all the world building for us in order to meet the huge demand that is going to be created. Some of the examples of neural graphics includes neural VDB, which is another powerful format which would be much powerful than the OpenVD which is available now. Plus, you will also be able to churn beautiful simulations at almost like 1/10 the size, plus 10x the more visual advantage. We're also talking about style GAN, which would be very helpful in creating photoreal humans. And also, you must have already tried Instant Nerve. Instant Nerve is another cool offering from NVIDIA, using which you can create visually replica of real worlds by with just few photographs of the real world. You can take some 10 pictures of yourself and go and create a 3D version of yourself seamlessly at a very short span of time. And we will definitely continue to throttle more on the power of USD, and we'll also keep launching a lot more tutorials and also create the awareness of the power of USD. The centerpiece is NVIDIA's Omniverse Avatar Cloud Engine, or it can also be called Omniverse ACE. So it's a collection of cloud-based AI models and services which will be available for developers to build avatars seamlessly and pretty easily. With ACE, developers can build, you can configure, and also deploy their avatar application across any engine, either in a public or in a private cloud. This is still under development, and please keep an eye and subscribe to NVIDIA's newsletters for an early access. All right. This is what I wanted to present for the day. I hope this gives you a very good understanding of where NVIDIA is right now and how it is empowering creators, world creators, developers in order to create beautiful metaverses. And we cannot wait to see what cool things you are going to create. And make sure if you have something cool created on Omniverse Create, please do send it to our social media tweets, or you can also connect with me on LinkedIn and share what you're doing. Thank you.